Thank you for joining me today. We have the first problem. We are given a truss and we are looking to figure out the internal forces in four members, AD, CD, AB, and BC, and the used method will be joint method. Regardless what is the requirement, I have to start with reactions. And keep in your minds, the reactions are not required. The problem did not ask for reactions. However, I cannot solve for these internal forces in these members without reactions. This is the reason why I have to start with reactions. So I have hinge at B. We have hinge at B. So looks like I will have two reactions, XB and YB. Two reaction at B. At A, it's a roller. So I will have only one reaction, XA. I have something here I would like to highlight. Keep in your mind, if you have a roller, most of the time your reaction is one reaction vertically. So if this one is A, this reaction will be YA. We used this since we started talking about reactions. But today your given roller looks like this. So your reaction will be like this. So keep in your mind, I can readjust the reaction or the definition of reaction at a roller. The definition of this reaction most of the time is perpendicular to the base of the roller. So since your roller in this case is a vertical, this is the base. So your reaction will be perpendicular to this base. Your reaction will be horizontal. That makes sense? So look to the base of the roller. This is the base. The only one reaction at the roller must be perpendicular to this base. Is it clear for you? Guys, is it clear, yes or no? No response?
Yes, it's clear.
Okay. So keep it in your mind. Yes, any roller, we have only one reaction. To be more accurate, this reaction is perpendicular to the base of the roller. So whatever the given base, I can assume the direction of the reaction to be perpendicular to this base. Okay, so we have these reactions in this problem. I have three equilibrium equations. Summation f of x equals 0. Summation f of y equals 0. Summation moment at any point equals 0. So go ahead and put your reactions. Go ahead and apply your equilibrium equations. What forces do you have in x direction right now? We have we have two. Positive xb, negative xa. Based on the direction I assumed for xb and the direction I assumed for xa, xb will be positive, xa will be negative. That's it, equals 0. I cannot do anything more because I have two unknowns. Summation f of y equals 0. We have negative 300. We have positive yb. In the y direction, we have this 300 in a negative direction. We have this yb, based on my assumption, it will be positive, equals 0. From this equation, I can find something. Yb will equal 300 positive means you assumed is a correct direction for YB, 300. The last equation, I'm gonna take moment at B. I do recommend to take moment at any point, but I do recommend to take moment at point with the highest number of reactions. So I'm gonna take moment at B. I will assume my counterclockwise is my positive direction. It's up to you. So I have 300 time. I have XA time. I have XB time. I have YB time equal 0. I have to list everything in this problem. 300, XA, XB, YB. Keep in your mind, I'm sitting at B. So what is the distance between YB and B? 0. What is the distance between XB and B? 0. What is the distance between XA and B? I think your distance will be 3 feet. And the 3 feet direction is perpendicular to the direction of XA. What is the distance between 300 pound and B? Since 300 pound in a vertical direction, your distance must be horizontal. It will be 4 feet. I don't care about the sign of this term. I don't care about the sign of this term. They will be 0. The 300 pound about point B will rotate counterclockwise, will be positive. XA direction rotating about point B will be clockwise, it will be negative. The only unknown in this equation is XA. I can figure out the value of XA. It will be, I think, 400. Let's see. Positive 400. If you go back here and put XA 400, the value of XB will be positive 400. So the direction of this XA is correct, 400, because it's positive. The direction of XB is correct, equal 400, because it's positive. So I am done with my reactions. If you have any question, let me know. This step is very important. You have to put the reactions. You have to apply the 3 equilibrium equations. You have to get the values of this reaction correctly. Next step. I will read carefully what is the requirement. Then I can decide how can I continue solving this problem. We are looking for member AD. This is your member AD, this one. And we are looking for member CD. This is the second member, CD. Stop. I will read only the first 2 members. Since the 2 members, the first 2 members intersecting at D, so the next step, I will work on joint D. So I will start here talking about joint D. Here is joint D. What do you have intersecting at joint D? Vertical 300, downward. And what else? We have this horizontal member with a force dA. So I have a horizontal force here, FdA. And I have this member DC with a force FDC. Nothing else. Nothing else at joint D. At this joint, inside this circle, we have this vertical force with this horizontal member, this inclined member. Nothing else. Keep in your mind that this angle theta will be the same like this angle theta. If you would like to set up right angle triangle for this this angle theta, I think we have this right angle triangle. 2, 1.5, and I can figure out the third one. So for this angle, I have 2 meter, 1.5 meter, and this is your angle theta. This is the triangle, right angle triangle for angle theta. That makes sense? And you keep in your mind, this one is 2, this one is 1.5. I think this one will be 2.5. So cosine theta will equal 2 divided 2.5. Sine theta will equal 1.5 divided by 2.5. Let's go back. Let's go back to angle D. Once you set up the angle, joint D. Once you set up the joint D, I can apply the two equilibrium equations. Summation f of x equals 0. Summation f of y equals 0. We have only two equilibrium equations because we are talking about joint, just 1 point. If you have 1 point, the equilibrium equation will be 2. Summation forces in x equals 0. Summation forces in y equal 0. Go ahead and put your numbers. For x, we have positive FDA. We have positive FDC cosine theta, the x component for this force, equal 0. Keep in your mind, this cosine theta will be 2 divided by 2.5. I cannot do it too much because we have two unknowns. Keep going. Summation f of y equals 0, we have negative 300. We have positive FDC sine theta equals 0. I think sine theta equal 1.5 divided by 2.5. The only unknown in this equation will be FDC. It will be positive value. How much? 300 divided by 1.5 divided by 2.5. It will be 500. If you go back here and put FDC 500, I think FDA will be negative 400. So the final conclusion, the value of FDA is negative 400. FDA negative means I assumed the wrong direction for FDA. I assumed it coming out from the joint, which is tension. Unfortunately, it's wrong. It should be compression. FDC equal positive 500. That means I assumed the correct direction for FDC. I assumed it tension coming out from the joint. It's correct tension. Does that make sense? If you would like to put these directions here, I can say this force is compression and it should be compression here. That makes sense? And this, how much for FDA? 400. And this force tension, and it will be tension from here. Excuse me. How much? FDC 500. So I am done with the first two members, FAD, FCD. The second two members, which are AB, this one, AB, and BC, this one. So don't be confused which joint I need to start or I need to work on. The two members intersecting at B. So this is your next joint. Does that make sense? So based on the given members, I can decide which joint I need to work with. So AB and BC, both of them intersecting at B. So my next joint will be joint B. For joint B. Here is your joint B. First of all, I have at B two reactions, one horizontal, one vertical, 400 and 300. That makes sense? 400 and 300. At joint B also we have the vertical member BA, FBA. And we have another member here in this direction, BC. Nothing else at joint B. I have to include everything intersecting at joint B. We have horizontal reaction, vertical member, and this member. That's it. Keep in your mind, I have angle here, I can call it alpha. Inside this right angle triangle, if you cannot figure out the value of the angle, put this angle in a right angle triangle. So this triangle, which here, this is alpha. So we have this right angle triangle, looks like this. This distance is 2. This one is 1.5. This is your angle alpha. And this is 2.5. So I can say sine alpha will equal 2 divided 2.5. Cosine alpha will be 1.5 divided by 2.5. That makes sense? So this is your angle for this member. I can put this angle inside right angle triangle so I can figure out the value of sine and cosine. Let's go back to the joint B. I will apply two equilibrium equations. Summation f of x equals 0. Summation f of y equals 0. What do you have in x? I have positive 400. I have negative FBC sine alpha equals 0. These are the only two forces in x, the x component of this force and the 400. Keep in your mind, sine alpha equal 2 divided by 2.5. The only unknown here is FBC. Your value will be positive. How much? 400 divided by 2 divided 2.5. I got 500. Summation f of y equals 0. We have positive 300. We have negative FBA. We have negative FBC cosine alpha equals 0. Cosine alpha equal 1.5 divided by 2.5. FBC equal 500. The only unknown in this equation is FBA. It will be, I'm not sure it will be positive or negative. Let me check. Wow. It will be 0. Based on the calculation. Let me check one more time. Yes, it will be 0. So that's fine. 0 is a number. So keep in your mind, FBC equal positive 500 equal positive 500. That means I assumed the correct direction for FBC, which is tension. It's correct. FBA equals 0, so it's not tension or compression. It's 0. So the force in this member will be tension, and it will be tension here also, 500. And this member will be 0. This is your final conclusion regarding member AB and the member BC. So I am done with the second two members. So keep in your mind, if you would like to solve this kind of problem, I have to start first with reactions and pay more attention to get them correctly. Then I have to read the required member 2 by 2. So the first two will guide you which joint I need to work with. AD and CD, both of them intersect at D, so I worked on joint D. The second two member intersecting at B, so the second joint I need to work in is joint B. Each joint, I have to apply two equilibrium equations, summation f of x equals 0, summation f of y equals 0. Each joint, I have to apply summation of x equals 0, summation f of y equals 0. If you got positive value, you assumed the correct direction. If you got negative value, that means you assumed the wrong direction. I should put opposite direction. Any question regarding this problem? Do you have any question? The second type of problem in this module, without calculation, how to identify the zero force members. For the given truss, without calculation, we need to figure out which joint are zero. Keep in your mind, just a reminder, the zero force members can be figured out without calculation if you have joint with two members only, no given external force at this joint, no reaction at this joint, the two members will be zero. Case number 2, if you have a joint with three members, two of these three members are collinear on the same line. No given external force at this joint, no reaction at this joint, then the third member only will be zero. First of all, go ahead and put your reactions. Don't find them, just put the reactions. I have here two reactions. I have here one reaction. Then I will redraw this truss one more time. This is my truss. I will redraw it using my pencil. And we are given this force 10. We are given this force 20. We are given this force 10. And we have these two reactions. How much I don't know, and I don't care. And we have this reaction. Let's start. I will start to check if you have a joint with two members only. Do you think we have a joint with two members only? Yes, I think we have G with two members only, but we have a reaction. Forget it. For joint A has two members only, but we have reactions at this joint. Forget it. The case saying that joint with two members without given load, without reaction. But this case does not exist. Let's try this case. Do you think we have a joint with three members? Two of them are collinear and no given external force or reaction. In this truss, I think if we are talking about joint F, we have this case. Joint F, we have three members. 1, 2, 3. Two of them are collinear on the same line. No given force, no given reaction, nothing at joint F. That means the third member, this one, will be zero. If you have a member which is zero, go ahead and remove it from the truss. Probably after you remove it, we can find more. I think we can find H. At this moment, I can say H is a joint with three members. 1, 2, 3. Two of the three members are collinear. This one and this one are collinear on the same line. No given force, no given reaction at H. The third member will be zero. So this member also is zero. If you have a member zero, go ahead and remove it. Probably we can find more. What do you think about joint E? What do you think about joint E? Joint E has three members, one, two, three. Two of them are collinear, but at joint E, we are given a force 10 kilonewton. Forget it. Unfortunately, I cannot do more. But if you go to the other side of the truss, we still have joint B. Joint B has three members. Two of them are collinear. No given force, no given reaction. At B, the third member will be zero. So this one also will be zero. I can delete it. Once you delete it, you will discover that we have another joint L with three members. Two of them are collinear, no given force, no given reaction. At L, the third member will be zero. So this one also zero. Go ahead and remove it and do another check. Joint C. Do you think joint C has three members? Yes. Two of them are collinear? Yes. But we are given a force 10 kilonewton at C. So that's enough. We are done. I'm trying to check more and more. I cannot find a joint with two members only. No force, no reaction. I cannot find any more joint with three members. Two of them are collinear, no given force or reaction at the joint. I cannot find any more. So the final conclusion, I have four members which are zero force members. I'm not asking you to provide why. I'm asking only just to circle, put a circle on the member which is zero. That's it. I highly recommend to redraw your truss with a pencil, and you can remove, you can delete the member which is zero, so you can discover more and more. Anybody has any question regarding this problem? I have another problem. We are given this truss, and we are looking to figure out the internal forces in these members, B, C, B, E, E, F, using a section method. Whatever the requirement, the first step, I have to start with reactions. You have to start with reactions. Sometimes reactions are not important, but we need to calculate the reactions. Okay, so this problem, maybe the reaction are not important, but the problem will ask first to calculate reactions. Anyway, we have hinge at A, so I will assume I have two reactions, YA and XA, like this. You can assume any direction, it's up to you. It's up to you. And at G, it's a roller. So I will have one reaction like this, YG. One more time. If you have a hinge, we have two reactions. You can assume any direction. The horizontal one to left or to right, the vertical one upward or downward. It's up to you. Once you set up your reactions, I have three equilibrium equations. Summation f of x equals 0. Summation f of y equals 0. Summation moment at any point equals 0. Go ahead and put your numbers. Summation f of x equals 0. We have positive 5. We have positive 10. We have positive 10, another 10. We have negative xa. Do you think we have more? In x direction, I think we have 5, 10, 10, and xa. Nothing else equals 0. The only unknown in this equation, it will be xa equal 25 kilonewton. 25 positive. That means I assumed is a correct direction for XA, to left. To left. Summation f of y equals 0. I assumed the YA down, it will be negative YA. I assumed the YG up, it will be positive YG. We are given 5 kilonewton down, it will be negative, equals 0. I cannot do anything more for this equation. I will take moment at A. I will assume my clockwise rotation is my positive. So if you take moment at A, XA will be multiplied by distance. YA time distance. YG time distance. 10 kilonewton time distance. Another 10 kilonewton time distance. 5 kilonewton time distance. Another 5 kilonewton time distance equals 0. I have to list everything. Keep in your mind, I am sitting at A. I am sitting at A. So what is the distance between XA and A? 0. YA and A? 0. YG and A? 4 meter. This 10 kilonewton and A, the vertical 4 meter. This 10 and A, 8 meter. The top 5, this 5 kilonewton and A, which is 3, 4 meter, it will be 12. And this 5 kilonewton at this joint E and A, it will be 4 meter. Keep in your mind. This force is a vertical force, so I'm gonna measure the horizontal distance. This force is a horizontal one, so I'm gonna measure the vertical distance. I don't care about the sign of this term, because they will be 0. YG time 4 will rotate counterclockwise, it will be negative. This 10 will be clockwise positive, the second 10 clockwise positive, the third 5 will be positive, and this 5 also will be positive. So if you have any rotation clockwise like this, it will be positive. If you have rotation counterclockwise like this, it will be negative. Okay. So the only unknown in this equation is YG. I can figure out the value of YG. It will be 40 plus 80 plus 60 plus 20 divided by 4. It will be 50. Positive 50. Positive 50 for YG means I assumed is a correct direction for YG. If you put here YG equal 50, I think YA will be positive 45. Positive means I assumed is a correct direction for YA, 45. So I started first to figure out the reactions. I put my reactions, the correct direction of your reactions. Next step, go ahead and see what is the requirement. We are looking to figure out the internal forces in member BC, this one. Member BE, this one. So go ahead and work with joint B. No, wait. And member EF, this one. We are looking to figure out the internal forces in these 3 members using section method. We have another method in truss analysis called the section method. How to use this method? I will start to cut my truss like this. How can I figure out this section, or how can I cut the truss? Just to go ahead and cut your truss through the required members. So I need to do this cut passing through members BC, BE, FE. This section will divide your truss to 2 parts, one at the top and one at the bottom. And you have to decide which part you are going to use. If you are using the top part, so the reaction are useless. That's fine. If you use the bottom part, the reaction are important to be determined first. Anyway, I do recommend it to use the smallest part. So I'm going to use the top part. If you are using the top part, which is one side of your cut, I think, so I'm working on the section method right now. So I think I will have this triangle without any touch this triangle for DCE. I did not touch this triangle. I have 5 kilonewton, 10 kilonewton at D and C. 5 kilonewton and 10 kilonewton. I have this 5 kilonewton at E. And keep in your mind, I did cut in this member. So I will have a force in this member CB. I did cut in this member, so I will have a force in this member EF. I did cut in this member, so I will have a force in this member EB. This is your top part. After you did your cut here, I decided to use the top part of this truss. So I redraw this part and I will apply summation f of x because we have a part f of x equals 0, summation f of y equals 0, and summation moment at any point equals 0 because we are talking about a part, not a joint. Does that make sense? The horizontal distance is 4, the vertical distance is 4, so any angle in this truss will be 45 degrees. So this angle will be 45 degrees. So let's start. Summation f of x equals 0. We have negative 5. We have negative 10. We have positive 5, positive 10, and the negative FEB cosine 45 degree equals 0. This 10, this 5, and the horizontal distance of this force will be negative. The only unknown in this equation will be FEB. I can find it. It will be positive. How much? 15 divided by cosine 45. It's 22.21. I'm sorry, 0.21. This is the first force. If you apply summation f of y equals 0, we have negative FCB. We have negative FEF. We have negative FEB sine 45 degree, and we have negative 5 equals 0. This one, negative. This one, negative. This one, negative. And the vertical distance of this one, vertical component of this force will be negative. Actually, I cannot do more here because I have many unknowns. Let's start with the third equation, summation moment at any point. I do recommend to take moment at E. I will take moment at E. I'm gonna assume it's up to you, my clockwise is my positive direction. I will let you know why I'm taking a moment at E. So I have to list everything. So I have 5 time distance. I have FEB time distance. I have FEF time distance. I have FCB time distance. I have 10 kilonewton time distance. I have another 5 kilonewton time distance. So I included everything. 5 FEF, FEB, FCB, 10 kilonewton, 5 kilonewton. Keep in your mind and remember, equals 0. We are sitting at E because I decided to take moment at E. So the distance between this 5 and the E, 0. This force FEB and the E, 0. FEF and the E, 0. So I can cancel all of these terms. This is how to be smart. I selected to take moment at a joint that can cancel as much as I can. And also, this FCB, the horizontal distance between the FCB and your point E is 4 meters. And this 10 horizontal. So what is the vertical distance between this joint and this joint will be 0. Another one will be cancelled. And this 5 and the joint E, the vertical distance is 4 meters. I think this one will be positive for 5, so clockwise, and this one will be negative. The only unknown in this equation is FCB. It will be positive 5. If you go back here and put CB 5 and put EB 21.21, I think the only unknown will be FEF. In this equation, it will be how much? It will be negative 20. Positive value for FEB, you assumed is a correct direction for EB, which is coming out from the joint. It's correct tension. FEF negative, that means you assumed the wrong direction for FEF. I assumed it tension. I'm sorry, it's compression. FCB is positive. That means you assumed the correct direction for CB, which is tension. It's correct. So by the end of the problem, I figured out the 3 internal forces in the 3 members, and I decided which one is tension and which one is compression. So guys, we have another method to solve your truss, which is called the section method. I will start to figure out the reactions. Then I will do cut, and this cut will divide your truss to 2 parts. I will decide to use one of these 2 parts. So I decided to use the top part after your cut. The top part, I redraw it, which is called free body diagram. Then I applied the 3 equilibrium equations. Summation f of x equals 0, summation f of y equals 0, summation moment at any point equal 0. That makes sense? Any question? The last problem, this one. I will first, regardless what is the requirement, I will start with reactions. Based on the type of supports, this is a roller, so I will have only one reaction, YG. This is a hinge, so I will have 2 reactions, XA and YA. So guys, as you know, as you see, the problems the same steps, typical. But the truss is a little different, but the same process, the same steps. If you apply summation f of x equals 0, if you apply summation f of y equals 0, if you apply summation moment at any point equals 0, you can find out your reactions. So summation f of x equals 0 is the only force in x direction is XA. This reaction will be 0. Summation f of y equals 0, we have positive YA, we have positive YG, and we have negative 4,000, negative 8,000, negative 5,000 equals 0. So I can say YA plus YG will equal 17,000, I think. If you take moment at any point, I'm going to take moment at A. I'm going to assume my clockwise rotation is my positive. So XA time distance. YA time distance. 4,000 time distance. 8,000 time distance. 5,000 time distance. YG time distance equals 0. I'm sitting at A. So the distance between XA and A 0, YA and A 0, 4,000 and A 9 feet, 8,000 and A 9 feet, so it will be 18. 5,000 and A, we have 1, 2, 3, 4, 5, 45 feet. YG and A, we have the total distance 1, 2, 3, 4, 5, 6, 5, 9, 6, 54 feet. Okay. This term will be cancelled, this term will be cancelled, this one will be positive clockwise, 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 this one is counterclockwise. So the only reaction here is YG. It will be how much? 4,000 times 9 plus 8,000 times 18 plus 5,000 times 45 divided by 54, 7,500. So YG equals 7,500. If you put YG here, 7,500, I can find YA. It will be minus 17,000. It will be 9,500. So this one is 9,500. I am done with reactions. We are looking for the internal forces in member AL, this member, and AB, this member, using joint method. So I have to follow what is the requirement exactly. So which joint I need to work on right now? Go ahead and see this member and this member, both of them intersecting at A. So this is my target joint. I will work on joint A. Here is joint A. What do you have at joint A? We have vertical reaction 9,500. We have horizontal reaction here 0. I have horizontal member AB, FAB. And I have inclined member AL, FAL. Nothing else. Nothing else at joint A. We have only 2 reactions and 2 members. That's it. So keep in your mind this angle theta, which is this angle theta. I can put this angle theta inside this right angle triangle. The horizontal distance equal 9, the vertical one equal 12. So the third one I think will be, let me check, 9 square plus 12 square under square root will be 15. So I can say any sine theta will be 12 divide 15. Any cosine theta will be 9 divide 15. Also, I will apply for this joint A, I will apply summation f of x equals 0, summation f of y equals 0. Go ahead and put your numbers. F of x, we have 0 plus FAB plus FAL cosine theta. This force, this one, and the horizontal component of this one. Summation f of y equals 0. We have positive 9,500. We have negative FAL sine theta. The vertical component of this one equals 0. Keep in your mind, sine theta from this triangle is 12 divided 15. The only unknown here is FAL. It will be positive value. How much? $11,875. If you go back here and put FAL 11,875 and your cosine theta is 9 divided 15, I can find FAB. It will be negative value 7,125. What you mean by negative value for FAB? I assumed is a wrong direction for FAB. FAB should be compression. Positive value for FAL, I assumed a tension, which is correct, tension. So keep in your mind, this direction will be FAB. is compression coming in. FAL is tension, like this and like this. That's fine. So I found the internal forces in member AL and AB. And I'm looking also for the internal forces in member CD, CJ, and KJ using section method. So for this purpose, I will do cut. And your cut will passing through the three members. And this cut will divide your truss to two parts, part on the left and part on the right. You can use this part or this one. For me, I'm gonna use the left part, which is the most easy part. So for the left part, for section method, I will draw this part, the members I did not cut, I did not touch. We have these members. Here is A, B, C, and LK. No touch. I did not touch these. We have these reactions, 9,500, and this one, 0. We are given a force here, 4,000, 8,000. At B and C. Keep in your mind, I did cut in this member, so I will have a force CD. I did cut in this member, so I will have a force CJ. I did cut in this member, so I will have a force KJ. So if you look to this part, which is identical to the left part after you did cut, and we have three members that you cut in, I will have three forces in these members. Once you set up your part, I will apply summation f of x equals 0, summation f of y equals 0, and the summation moment at any point equals 0. You can find out, once you set up these equations, you can find out these forces in these members like we did in the previous example.